Hello everyone, this is Mohammed from Python Ninja YouTube channel, and in this tutorial we will introduce recursion functions in Python. In data structure there are two common approaches to iterate over a tuple object. A tuple object like a list or a sequence of letters or tuples. So we can iterate using two common approaches. The first approach is the iterative approach, which is used in for loop, and the second approach is called recursive approach. In recursive approach, or the recursion, is defined as an iterative mechanism that makes a function call itself from within. So we recall the function inside the function. We will learn together how can we recall the function inside itself, or it's like a footprint. The recursion also is situational, meaning that there is no specific rule for the recursion, okay, and based on the implementation and based in the use case, we can employ the recursion, and it can help in reducing the implementation couplets of the algorithm, and we should take care about the best way to employ the recursion and the number of steps that we will use just to meet the memory allocation and requirements. So let us start by coding using an iterative approach. We will use for loop to simulate a function that is used for or inside a robot, and suppose the robot will move for a fixed number of steps with a straight line, and we want to print at each step. We want to print that the robot move, for example, one step, two steps, three steps. We can define it using a simple iterative approach. For example, we will call this, for example, robot step, and we will pass the number of steps, okay, as an argument. And I want to iterate, okay, using an iterative approach for I in range, and this range will be similar to the number of steps that I will pass. What I will do, nothing, but I will print, okay, for example, I will print the robot, okay, moved, and I want to open, because the iterative approach started from I, and the first I is 0, so I want to use I, which is 0, and I want to add 1 just to simulate that we started from 1, not from 0. And just to, this is the whole procedure, and I can recall the function now, robot. Okay, step, and I want to move, for example, 10 steps, and I want to show you that the robot move 1, 2 till 10. And to add some beauty, I can import time, and I just add a pause here, just to leave the execution, for example, for 0.3 of the second, and now we can see how the robot is moving from 1 to 10. This is the implementation of the function using the usual iterative approach. I can repeat the same function using the recursive approach, from which we can recall the function inside its footprint. What I need to do to redesign this function using the recursive approach or recursion, I want to use the same function. I want to call it robot step, okay, and I want to use it for recursion, and I want to pass the same number of steps, okay, just for the sake of reproducibility. What is the first step in designing a function based on recursion? Is to consider the base condition. What is the base condition? The base condition is the condition that is used inside the recursive function to stop the recalling the function or recursively. Again, we need a stop condition or base condition. By using this condition, if the function reaches that condition, then there will be break and no recall to the function recursively. So if this is the first thing, every recursive function, when you design any recursive function, consider to include the base or stop condition to stop recalling the function recursively. Otherwise, we will fall with a recursive error and memory error. So the first thing is to design this base condition. So if the number of steps will reach to 0, okay, then I will do return, just the word return. What this word return or the statement return do, it is execute, it consider the like a break. It's so return is used to break the function and return the result. Okay, this is the main use. Okay, so I designed the base condition. What is the second step to design the recursive condition? In our function, in the top function, it's nothing but printing the number of steps. So I can recall this function inside the function itself. So robot step break, which is this one, is recalled. But now, because I want to move, for example, step 1, step 2, step 3, meaning that if I pass 10, then I want to go to 9, 8, 7, like this. So it is nothing but the number of steps minus 1. Okay, and I will do the same here. I will use the time.sleep. I will show the execution. Okay, then I will describe more. Okay, and I want to recall the function with the recursive here or the step break function 10 times. Let us execute this function. Okay, this is the iterative one function. Okay, but here I have also to print the number of steps. Print. I want to copy this one. Okay, but I have to modify instead of the number of I plus 1. I want to print here the num steps. Okay, again we pass, for example, inside the function 10, then this will be recalled to 10 minus 1, which will be 8, and we will print 8. Then we recall the function again, 8 minus 1, which will be it will be 9. 8 minus 1, it will be 8. Okay, and it will recalled again. Okay, inside the function again. It will become 7, and 7 will be printed. And again, we will recall this. It will become 6, and a 6 will be printed. Again, it will minus 1. It will be 5. Then it will be 4. It will be 3. It will be 2. It will be 1. And 1, if we recall it again, 1 minus 1 is 0. And here the number of steps are 0. Then we return, we revoke the function. We break the function. So this is the first approach, which is the iterative one, and this is the second approach. Okay, so if I remove the first approach, the iterative approach, and I keep only the recursion, we have the same thing. We print 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and that is by recalling the function itself, which is typical to that name, and by reducing the parameter, which is numerical here. I can reduce it by 1, then reducing it by 1, then I consider all of this. I reducing this by 1, and I can update the minimization till reaching to 0. And if I reach the number of steps 0, then I return the function. I break the function. How does that work exactly? Let us just consider this. Okay, in the above example, which is this one, okay, I have this function, okay, I recall this function with the number of steps, okay, and I hear the steps equal to 10, okay, so or how Python can execute this function. In the first stage, there are frames that are created or added to the memory. Once I recall the function, which is this one, the interpreter will create frames inside the memory. What are what these frames do? The frames are nothing but the function, okay, with the original value, then the function with the original value -1, then the function with the like the previous value -1, the previous value -1 till reaching to the function with the previous value, which is 1 -1, which will be 0, which is this one. This is in the top of the stack. So it's like this. Suppose I have this function, I recall this only for 3 steps, okay? So I will print 3, 2, 1, 0, okay? This is the exit. Look at this, okay? Only this part. In the first case, we have base case or base condition, and this base condition, for example, will return to us 0, okay? This will return to us 0, which is this one. This is the base condition to me, okay? Then I recall the function, okay? The stack, there will be stack of of frames, okay? Or there are frames that are stacked on top of each other, okay? This is the function, the first one, which contains the original argument, for example, 10 or 4. Then the second one, which is placed in the top of the original one. Then we have another one, which is the 3, which comes from the top of 3. So the value will become 0 for the base condition. Then it will become 1, okay, for this case. It will become 2. It will become 3 if I like print this from bottom to top, or vice versa. So this is how the stack are created. So think of this, okay, like this, okay. We have a function. I recall the function like this. I recall in normal case, I recall the function like this, okay. This is the recursion, how it does. It will become 9. It will become 8. Okay, this is for this application, because this application is nothing but the original steps -1. Okay, till reaching, okay, this 0, and this 0 meaning that the number of steps here is 0, and if number of steps is 0, then we will use return. The return will revoke, will break the function and stop the execution. And this is the frame that is created inside the function. Okay, so we create this frames, and this frame can be printed. I printed this for each time. I print this from the lower, okay, from the number of steps. Okay, will be printed from 1. Okay, then it will print 2 till 10. Okay, which is like this, okay, and this will be, sorry for this typo. And by this way, the recursive approach create frames, okay, in the memory, and the number of frames is a function of a number of steps. For example, if I have 5 steps, then we will have, because we reduce the number by 1, okay, till 0, so the number of frames will be 5 here, okay, and in each frame there will be value for number of steps. For example, in the first frame the value is 1, in the second frame the value is 2, okay, and in the top frame the value will be typical to the number of steps, okay. And this is how we recall the function. If I have the function in the stack number 2, then it will be just return number 2, which is 1 by 1, and the top function, which will be 2 plus 1. But I prefer take this to increase your comprehension. And by this way, we can design any function recursively only by considering the base condition. Then we recall the function itself. Okay, and if I need any function that will do counting or count down, to me, I can use this or count up. Consider one thing here, that the number or the place of the print statement matter here. For example, let us move this and we describe this. Okay, and let us speak of that later. Now, consider that when we recall the function here, okay, we pass the number of argument, okay, of the number of steps, which is 10, and we create the frame. This line create a frame. Okay, for example, if I pass 10 like this here, if I pass 10 here, okay, then I recursively recall the function, okay, because we recall the function inside this function, we call it recursive, okay. We recall the function 10, okay, minus 1 will be 9, will be 8, will be 7, will be till reaching to 1, and 1 minus 1 is 0, then we will go to return, which will break the function, okay. Now, we consider a print statement, okay, like after create. So in this line we create the frame from, okay, from frame number 10 to frame number 1, okay. Then we place a print statement, okay, in the top frame, which is number 1, and we print this frame, and then we take pause and print frame number 2 and print frame number 3, okay, till reaching to print the value. We don't print the frame, we print the value of the frame. But if I cut this line and I print it in the top, I use it in the top, what the case will be? The case will be like the opposite side, or the inversion. How the inversion will be? I pass, for example, here 10, okay, and 10 will come here. Then we will print the number of steps, which will be 10. So instead of printing 1, we will print 10. Okay, then we have the recursive function, and we reduce 10 by 1, which will be 9. Okay, then, okay, we go the top and check. If it equals 0, no, before going to check, we print 9. Then we print it. So if I execute this line, it will be printed from top, okay, 10, okay, to 0, okay, because I move this print statement to the top, and it become now before creating the frames, and or at each time we create the frame from like 10, okay, it will print 10, then it will print 9. But if I move this line after recalling the function, then it will print the frame from the top, okay, which is frame number 1 to the highest one, or to the bottom one, which is the frame number 10, okay, or to or the first the first bigger frame. So this is the case. Here we create the frame from the bottom, okay, in this line again. Then we add 9, 8, 7, 5, 6, 5 till 1. After that, we place print statement in the to print a value of frame number 1, frame number 2 till frame number 10. Okay, I hope that's clearer now. Remember that if we I think I also included this in the description. Remember one thing, in practice we can use either iterative or recursive approach. So we can use for loop, or we can use recursive, that's situational and based on the program itself. What if I recall this function for 15 times? It will be printed the frame from 1 till 15, yeah. But what if I have 150 times? Then it will be printed. Okay, that's okay. Let's increase this little bit so my memory is good. I want to print this for 1,000 times. Then we will have a problem here. This is the drawback of using the recursion, which is the recursion error and the maximum recursion depth. Okay, exceeded in conversion, meaning that when I recall this function, in the memory, we created 1,000 frames, and these frames are stacked on top of each other, and that exceeded the memory location or the memory space, and that's one of the drawbacks of using the recursion. And there are many ways to optimize the recursion and the function calling or recursively. We will share the light in like next tutorials on that case. One of this approach, like using cache. We will learn together how can we like build a cache, and or can we use like already designed cache using context manager that like that comprises some caches to optimize the number of frames and the memory spaces. Let us like highlight another example before closing this tutorial. We will have two examples here, and yeah, I have this first example. Let us just copy this and place it here. Okay, and this is the example. Okay, let us create a function that adds number to its decreasing sequence. What does that mean? If I want to add the number to its decreasing sequence, which is similar to 5 plus 4, okay, plus 3 plus 2 plus 1. This is the decreasing sequence of a number. Okay, if we can we can create this, for example, recursively. For example, this recursively, and we want to consider to add the number. Okay, for example, if it's 5 will be similar to this. If it's 10 will be 10, 9, 8, 7, 6, like this. Okay, now we agreed that if we design a function using recursion or recursively design function, we need the base condition. What is the base condition? The base condition is the first line that will break the function. If number will be 0, then I want just to break and return. I can return 0. I have nothing. Okay, this is the first base condition I use. Else what I will do, I have to do return what? I want to return the number, which is 5 in our example, plus, okay, plus what? Plus the decreasing sequence of 5, which is 4, which is taken from the recursion of the number, okay, minus 1. So we return here, if it's not 0, we take the number, which is 5, and we add it to the recursion minus 1. So here we will have 5, okay, and recursively we reduce 1 of 5, 4. Then the num become 4, and recursively reduce 1 become 3, and 3 become the num, okay, and recursively reduce number 1 from 3, we will have 2. 2 becomes the num. And recursively reduce 1 of 2, it become none. It become 1. Then 1 become num, and 1 minus 1 is 0. And if num is 0, so num becomes 0, then return 0. Okay, so we can take the solution from this case. If I want to print, for example, the add recursive number, okay, I want to consider 5. And if you add 5 plus 4 plus 3 plus 2 plus 1, it will become 15. You can add, for example, 100, and just you can add them recursively together. Okay, now let us give another thing. In mathematics, there is another example that is used for practice the recursion, which is called the factorial. Okay, what is the factorial? The factorial is used by using exclamation mark. Okay, for example, of n, which will become n. Okay, multiply by n minus 1. Okay, multiply by n. Okay, minus 2 till, we call till 1. So if I have 5, so the factorial of 5 is 5 multiplied by 5 minus 1 multiplied by 4, then minus 2, which will be 3. It's similar to the above example, but the above example was, the previous example was for the addition, but now we will have something for the multiplication. So if the factorial of 5 is nothing but 5 multiplied by 4 multiplied by 3 multiplied by 2 multiplied by 1, this is the factorial. Okay, and this is the character we use or the annotation, the notation used in mathematics for the factorial. So in the previous example, instead of multiplier, we use addition. Okay, so we can design the function by using iterative approach. Okay, so we have the factorial. I want to pass the number here, and I can have the condition of the result using the iterative approach. For example, I can identify the variable here, which will become 1, not 0. If it will become 0, all the result will become 0 because I want to multiply the result with the sequence. So if the number will be greater than 0, okay, so if I pass, for example, 5 and 5 greater than 0, then I will go inside for I in range, because we use multiplication, we want to start from 1, not num like this, because this for loop will start from 0, so we will start from 1, and we do shift of num minus 1, plus 1, and this is the placeholder or the variable that is used to show the result of the factorial. So in this case, the result using the augmented assignment operator, nothing but the result star equal 1. So you can obtain the factorial using this line. So you can also return the result here, and we can print the factorial of 5, and the factorial of 5 is 120. And remember, we will repeat the same thing, but not using the iterative approach, but using the recursive approach, or the Python recursion. Look at this implementation. I want to give factorial, and using the recursion, I want to get the numbers similar to what I do. We need to design the base condition. Remember, the first step in designing any function by recursion or designing a function recursively, you need the base condition. What is the base condition? If number equal 1, do nothing but return 1. So break the function and give me 1. Else what you will do, the same when we use for addition. We will use the number which, for example, could be 5. Then we multiply this number by what? By the factorial of the function, not this one, the factorial of recursion of the number, but minus 1. So in the debugging, we will have, if we have number equal, for example, 5, then the factorial of 5 in this case is equal to num. So num is 5 multiplied by what? Num minus 1 multiplied by 4. Then num become 4. Then 4 minus 1 multiplied by 3. Then num becomes 3. 3 minus 1, 3 minus 1, which is 2. And num become 2. And 2 minus 1 become 1. And now we have num equal 1. Then we return, we break the function and return only 1. And inside the result, we will have this. Just remember that at the return, otherwise, sorry, and we will add the return, okay, to this line, and I want to print the same thing for this line, but with this function, factorial recursion, and we would recall we have the factorial using the iterative approach, which is this one, and the factorial using the recursive approach, this one. Remember, please, that you need the first thing to design in the recursion is the base condition. Okay, the base condition is the condition that is used to break the calling the function recursively, like this. Okay, then whatever the application is, you can use the recursion based on that. So by this case, we estimated or computed the factorial of the number. In the previous example, we instead of estimating the factorial, we added the number to its decreasing sequence. In next tutorials, we will shed the light on another application of the recursion. And I hope that I simplified the theory behind the recursion as much as I can. And that's for today's tutorial. Please share this video and press like to enable me recording more videos, and share this video to any beginner who want to learn for free.